Wouldn't notice anything. They're all increasing. Okay. Look at the equations really quick. We've got log of base 10, we got log of base 5, and log of base 2. Look at how the graphs are shaped. Can you make any conclusion? So log of base 10 is the red, log of base 2, log of base 5 is the purple, and log of base 2 is the gray. Can you see anything? Okay, so here it is again. 10 is up here, 5 is here, 2 is here. What do you notice? What's happening to the graphs as we go down in base? They're getting closer and closer to the x-axis, maybe. I gotta wake up. I know it's Wednesday. Wake up. Okay. So as we change the base, it gets closer to the x-axis. And I'm going to say as we decrease the base, sorry. So as it goes down, it's getting closer and closer. Okay, so today we're going to graph logarithmic functions and identify their key features. Okay, so we have log of base 3 of x. Okay, with logs will have a vertical asymptote. Okay, that's what you need to know. Logs will have a vertical asymptote. Exponential functions are going to have a horizontal asymptote. Okay, so over here, we have a vertical asymptote at x equals 0. Okay, so we have a vertical asymptote at x equals 0. The way that we can also see this in the equation is it's whatever the number is that's added to the x inside the parentheses. Okay, so since there's nothing written next to this x, that's going to have a vertical asymptote at 0. Okay. For the domain is going to be wherever the vertical asymptote starts all the way to the right. Okay, if it was flipped, like if the equation was over here, then we would go to the left, obviously. But for now, we're going to say from 0 to positive infinity. Now, is this function increasing or decreasing? Is this function increasing or decreasing? Increasing. And it's increasing the entire time. So we're going to say from 0 to positive infinity. So from the domain, which is the entire time, it's increasing. So for in behavior, we're going to say as x is approaching positive infinity, so as we're going to the right, where is it going? Well, it's going to also positive infinity. As we move to the left, it doesn't go to the negative infinity, like it doesn't go to the left that much. It only goes up to 0. So we're going to say as x is approaching 0 from the right-hand side, y is approaching negative infinity. Okay, because I'm that kind of person who likes cheat codes, I'm going to give you kind of like where would you find each one of these things in this equation. So for the vertical asymptote is what is added to x, like inside the parentheses. For your domain, it's going to be your vertical asymptote and either to positive or negative infinity, depending on how the graph is facing. It's going to increase or decrease based on your domain. And your in behavior is always going to be, probably with logs, going to be either positive or negative infinity in one or either of the directions. And again, we'll look at that a little bit more in detail. Can you try this side? Can you try to fill that one in? Okay. So what is the vertical asymptote on this guy? Not -2. Look at the graph. 2, okay? But it is going to be the opposite sign of this guy, okay? So we're going to say x equals 2. Okay, what's the domain going to be? What's the farthest left x value? Well, you told me that there's a vertical asymptote at 2. Okay, and we're going to go to the right, so that's positive infinity. Is it increasing or decreasing? Increasing, right? So that's going to happen from 2 to positive infinity. Now, in behavior, that means as x is approaching positive infinity, where's our y's going? They're going up. So that's going to positive infinity as well. As x is approaching 2 from the right-hand side, y is approaching negative infinity. Okay, the one transformation that we have is this move 2 units to the right. This also has a base of 3. And that's one thing that I didn't mention over here. This one also has a base of 3, which is slightly a transformation, but you could kind of consider this a parent function depending on the question. Okay. This one moved 2 units to the right. And we can see that from that -2. So now let's talk about the range. Okay, so I need to go back. Okay. Yeah, okay, hold on. Okay, so range is going to deal with my y values, right? So it's how far down does it go? I'm going to be perfectly honest with you. This is going to have a range of negative infinity to positive infinity. And that's probably going to be for a majority of your stuff. Okay, it kind of looks like this is leveling off at 2. But if we actually graph this out, this would continue on forever in the positive direction. Okay. Great. Your x-intercept is going to be where it crosses the x-axis. So where does this guy cross the x-axis? 1. Okay, so we're going to have 1, 0. Is this decreasing at all? No, we already established that on the last one. And does this guy cross the y-axis? Does this cross the y-axis? Chris said no. Anybody else say no? It doesn't touch it, right? Because it has that vertical asymptote, right? So if it has a vertical asymptote at that x equals 0, then we're going to not have a y-intercept. Sometimes that'll be the case. Sometimes you might have a y-intercept. Just depends on the equation. Can you try this one over here? Okay, so what's the x-intercept? Where does it cross the x-axis? 3. Okay, does it cross the y-axis at all? No, because it's got that vertical asymptote at 2, right? That means it does not cross 2. So it doesn't come over here. It also does not decrease. Okay. Ta-da! What you mean? With logs and like exponentials, yay, Desmos. With logs and exponentials, the key features aren't horrible. You just got to know what you're looking for. Go ahead and sign into Desmos. So go ahead and take out your laptop. We are not going to do all 25. You're going to go to student.desmos.com. We're going to work a couple of these together, and then I'll give you some time to work on it by yourself. All right, so let's talk about this. So we created this little table. We just filled in some X values. Okay, and so you want to ask yourself, what to the second power would give us 9? What to the second power would give us 9? Fantastic. What to the second power would give us 9? 3. Okay, so that works for this one. What to the first power would give us 3? 3. Okay, so this guy is in base of 3. Okay, the way I got that is by taking these points right here. And remember, our y value is going to be our exponent. Okay, so going ahead and going to the second one, we already said that the base is 3. And how do we figure that out? Well, we use our exponential, right? So you're typing in here, the base is 3. And then you're saying, by taking the exponent and figuring out the base. So like kind of like doing this, x squared equals 9. So that would be 3 squared equals 9. We worked that for a couple of different points. Anybody want to take a guess at what this one is? So ask yourself right here, what the first power would give us 10? What to the first power would give us 10? What to the first power equals 10? What to the first power would equal 10? 10. Okay. So our base is going to be 10. Number 4. Slide 4. Oh, we move forward. Okay, so we have a base of 10. And how do we figure that out? Well, we looked for when y was 1, what was our x value? Okay, so find 3 more points that will be on the graph, b of x, and add them to the table. So if we add in a couple of x values, well, it doesn't automatically tell us, right? So we're going to have to calculate that. So when we come up here, we're doing log of base 2 of x. Okay, remember your Desmos graphing calculator does this for you. So you can come in here and you can go to the little keyboard and go to functions and go all the way down to where it says log of base a and type the equation in. And now we can fill in a couple and then put them into our new table. Okay, I would highly suggest trying this on your own. Definitely utilize the graphing calculator. Yes. Yes, go ahead. Whole numbers. What are some values from this table that I can pull that are whole numbers? So we got 4, 2 and 2, 1. We can come in here. We can type 2, 1 in here. And they already have 4, 2, so we're going to have to find another one. So 8, 3. down. Okay, so a colony of bacteria bubble every hour. We want to write the equation for this scenario. Okay, so when you come in contact with these kind of scenarios, remember, you're going to use that whole y equals a times b raised to the x. So what is a? Well, a is going to be our initial amount. How many bacteria do we start with? 1,000. Okay, and then what is it doing every hour? Doubling, so that's going to be 2. So how do we determine the number of bacteria after 3 hours? How do we figure out the number of bacteria after 3 hours? Yep, so y equals 1,000 times 2 raised to the 3rd power. If we take this and we plug it into our calculator, we're going to get 8,000. Okay, now we want to sketch an image of the equation. Okay, so what we're going to do is we're going to go into Desmos because it does it for us. Okay, we're going to go into Desmos. And we're going to say 1,000 times 2 raised to the x. Our sketch is going to look like this roughly. How would we determine how many, 100,000 bacteria? When would this take place? Well, we could go into our table and we can look at when our y value hit 100,000. So we can plug in x values to see when it hits 100,000. Well, it happens probably right in here. So in the hour of 6 to 7. About 6 to 7 hours. Okay, so from the warm-up, for the colony of bacteria, we can write the equation. We've already done this one. 1,000 times 2 raised to the x, where b of x represents the number of bacteria and h represents the number of hours. We can also write the equation where b of x represents the number of bacteria in thousands and h represents the number of hours. Okay, so we could say 1 times 2 raised to the x. Okay, so the difference between these two is now we're saying that the bacteria are in thousands. Okay, sometimes you might see your equations written like this. You have to pay attention to what it's measured in. If it says in a certain number, sometimes it'll say like in millions, talking about money or something like that. You got to make sure that you pay attention. Okay. On this next graph, it says make 2 observations from the graph. Okay. What's one thing you notice in this graph? Okay, so it's doubling every hour. Okay. Intercept is at 1. That's it. That's a point. Yeah, so this point is 2, 4. Okay, keep thinking. One thing I do want you to pay attention to is on this side, it says in thousand. Okay, so how long would it take for when the colony reaches about 10,000? So how long would it take for it to reach 10? Well, that would be roughly about 3.25, right? Looking at the graph, it's got 3.25. Okay, 72,000, how long would it take for that to happen? What's your estimate? How long would it take for it to hit 72,000? Well, that's going to probably be about 4 to 5, maybe. So if we wanted to actually solve the number of hours it would take for our original function, we could express it as this log of base 2 of b. Okay, so use this equation to fill in the table. So go ahead and take a moment, go ahead and fill in this equation, or fill this in these y values. Okay, and you can use Desmos in order to do this if you want. So take a moment, you're filling this in, and I'm gonna ask you. All right, so what'd you get for your y values down here? Yeah, go ahead. When x is 1, what's y? Okay. And then when x is 2, what's y? Okay. When x is 4, what's y? When x is 8, what's y? When x is 16, what's y? Okay. What are you noticing between these two? Look at the table. There you go. Okay, so this has XY, and then this one is switched. Okay, so I could probably tell you that 49.87, the Y value is going to be 5.64. Exactly. All right, so make 2 observations from the graph. Okay, so looking at this one, it says make 2 observations from the graph. So what is one observation that you see? I see that our X values are measured in thousands. Okay, I also see that my hours are on the Y axis. Okay, so how long would you estimate for when the colony reaches 10,000? So we're looking at when X is 10, what is Y? So what is Y roughly? 1, 2, 3, about 3.25, right? What about 72,000? So when X is 72, what's Y roughly? About 6? This is very much different from what we learned earlier about the key features. Since we are listing them in context, remember, we can't have negative numbers, we can't have negative bacteria, okay? So for domain, on this first one, we're talking about the graph on the left, okay? The domain is gonna start from 0, okay? That's our X value. And we're going to go all the way to positive infinity, okay? Or we could say, since this graph only tells us about the 4, we could say that. But we can go ahead and list positive infinity because we know that time is continuing on. Okay. My range is going to be my lowest Y value, which is 1. And my highest Y value is going to be positive infinity. There is no x-intercept because it doesn't cross the x-axis, but my y-intercept is at 0, 1. Okay, the end behavior is going to be as x is approaching positive infinity, y is approaching positive infinity. As x is approaching 0 from the right-hand side, y is approaching 1. And it's a positive interval the entire time it's on the domain. Okay, so let's talk about the second one. So the domain is going to start from right here and continue over. Now, I personally cannot see that. So what I'm going to do is I'm going to go into Desmos and I'm going to graph it myself because my eyes are the worst. So I'm going to go to the little keyboard. I'm going to go to functions. I'm going to go down to where it says log of base A. And it said log of 2 of x, correct? Now I see it crosses the x-axis at 1, 0. Okay, so going back to my little graph. Okay. I see that it's going to start at 1 and continue on to positive infinity. My range is going to go from 0 to positive infinity. There's an x-intercept at 1, 0. And there is no y-intercept. Now, as x is approaching positive infinity, y is approaching positive infinity. As x is approaching 1 from the right-hand side, y is approaching 0. And it's a positive interval the entire time on the domain. So notice how these two things kind of switched. Like the domain and range kind of flopped. The x-intercept and the y-intercept flopped. And so did the end behavior. Okay, so they just kind of switch because these two functions are inverses of each other.